So I want to talk about the let's call this the Kummer theoretic interpretation of this dude here. Okay, so this is just a single lemma. I'm going to try and make this quick. So the lemma is as follows. So let K be a field. And it says that H1 GK of Z hat 1 of K bar. This is isomorphic to, there exists an isomorphism, which I want to describe, and I'm going to call it delta hat inverse, to K, the units completed. So here, Z hat 1 is this inverse limit of these group schemes here, U and K, and when I evaluate at K bar, I'm taking the K bar points. And then this K cross hat, so this is K cross, so it's the limit of K cross mod K cross to the N. Okay, so I just want to describe what this map is. So let me describe what this map is, like I said. So, so the baby version is always with roots of unity. So maybe we saw something like this in there's another video where I do this in the Arizona Winter School, where you always do the Kummer sequence. Whenever you do a Kummer sequence, this is the Kummer sequence. I'm going to write it down. It's usually for group schemes, but I'm going to write it down for points here. I don't know if I said this, but here, K bar in this setting, this is the algebraic closure. Okay, for this field. So this is multiplication by n. The kernel of multiplication by n is the roots of unity, the nth roots of unity. And so this is an exact sequence of GK modules. Okay, because GK acts on all of these things, and all these maps are equivariant with respect to this GK action. GK is the absolute Galois group of K. Okay, so this is the Galois group for K bar over K. All right, and so we can take cohomology of this. So taking group cohomology, okay, what do we get? Okay, so when we take group cohomology, we will get, and I'm just going to start here, the H0 term here. So we have the short exact sequence, and to every short exact sequence, there's an associated long exact sequence. And so we'll start with H0 of GK K bar times. Okay, so H0 is taking Galois invariance. Okay, and this one's multiplication by n again. GK K cross here. And now we're at the end of this sequence, and when we go to the end of the sequence, we start going to H1. Okay, so K bar, like so. And then it continues to H1 GK K bar cross, like so. And then it continues as so. I guess there's some other terms here too. Okay, there's the units one here. Okay, so now what does this have? So this thing here, this goes away by Hilbert's theorem 90. Hilbert's theorem 90. And now we have this part of the sequence where we're going into 0. And whenever you have a sequence like this, you can see that you'll see that the co-kernel of this map is isomorphic to this one via this map. And this map here is delta of n. So this is the connecting homomorphism when I'm going to take the nth torsion here. Other things that we can see is we can see that this thing, so 0th Galois cohomology is taking invariance. So this is just K cross, and this is K cross, like so. And now we have the following. I'm just going to copy this over. And I'm going to say what I said before. So we have this co-kernel map, which is multiplication by n from k cross to k cross. Okay, so we take the target modulo the image. So this is k cross modulo k cross to the n. Okay, and then we had this map delta of n. Okay, so this is the induced map. Because this is an exact sequence, the image of this is in the kernel of this map. So the map is well defined on this quotient, which is the co-kernel. And then this goes to h1 of gk. And we had k, or what did we have here? Oh, sorry, so this is incorrect here. So this should read this should read mu n k bar. Okay. Okay. This should be mu n k bar. Okay, and that this is an isomorphism. All right, now what do we have? So now we have this isomorphism between this and this. Okay, and we're almost to the end of the statement. We just need to take the limits. So we take limits of all these, and if we taking limits gives limits gives the limit of this thing. So I take the limits of all these maps, the inverse limit here of these delta of n's, we'll call this delta of hat. Okay, and then we'll take the inverse limit here. Okay, this guy, I think that this is true because of representability in the derived category. You can see the video there. This is a quick way to do this is that representable, whenever you have a representable functor, then you can show that there's commutation like this. Okay, so we have this thing, and then this is z hat 1 k bar. Okay, so that's what this is. And then here, this is what we called k hat. All right, and so if we were to invert this, this is the map that we get. It's the inverse of this connecting homomorphism. So this inverting, so we get this delta hat inverse. This gives us the isomorphism that we're going to use a lot. And then I'm going to omit the taking the k bar points there to k cross hat. Okay, so this is the description of the map. So this inverse of these limiting, the inverse limit of these. So the inverse of the inverse limit of these baby Kummer maps. All right, that's what I wanted to say about that.